This is an economic systems analysis of an open pit gold mine, presented to you by Michigan Tech systems engineering students in order: Logan Smith, Brennan Sokol, Brianna Charlot, Andrew Houston, and finally Connor Pruitt, with a special thanks to our geological and mining engineering team members. Also, and thank you to our sponsors, Core Mining and GRE. So a quick overview of our presentation. First, we're going to go over our project background, then problem definition, mine operations diagram, economic model, environmental models, and finally our conclusions and recommendations, as well as acknowledgements. So the project location is the Imperial Mine, which is located in southeastern California. There's a number of nearby mines that suggest there's a significant potential for profitability, hence why our sponsors have asked us to model this location.
The problem definition is outlined by aspects that include modeling the net present value, which we then performed a sensitivity analysis on to test the variability. We also explored a life of mine design to determine a likely operations process of this particular mine. Lastly, we conducted an assessment of possible worst-case scenarios based on 100-year event data used to produce environmental models. The mine operations diagram maps out a general life of the gold in the mine from the primary stages of stripping and removing it, washing it in a cyanide heap leach to dissolve the gold, which then produces a gold solution that gets collected and later sold.
To determine the net present value of the mine, we created an economic model using Google Sheets. And so we started with a couple of key assumptions, namely that our operating costs are linear within the modeled range, and also that higher grade ore is crushed before being sent to the heap leach so we can get a higher percentage of the gold out of it. Additional inputs to our model included the variable inputs in the table at the bottom of the screen, as well as some constants from literature and from our preliminary economic assessment from our sponsor, plus a few assumptions. Then we take all of those inputs and use them to perform some intermediate calculations, namely our operating costs and revenue that we can expect from the heap leaching process. And then all of that goes into a discounted cash flow. So that takes revenue, capital and operating costs, as well as depreciation, depletion, and a couple of other items, and gives us our net present value.
We also developed a causal loop diagram to map out the relationships across the mine, shown on the right. The main environmental considerations are highlighted in green. These are dust and water. We use several guiding questions to measure and determine the risks within each. For dust, these were: which direction will the dust travel? What is the pollutant concentration? And will any nearby cities have major concerns? For water, we asked how much risk is associated with the leach pad, what is the risk of wildlife pollutant consumption, and what are the impacts of using the ideal cyanide concentration.
In conclusion, our model predicts that the mine will have a net present value of $430 million US. Our recommendations for the Imperial Mine project to combat dust is the usage of either water misting machines or dust collector vacuums. And to prevent water contamination from the heap leach, we recommend installing geomembrane liners and additionally implementing break walls to funnel the runoff to a pump, preventing water pools from forming. We would like to thank and acknowledge our project sponsors, fellow mining students, and all of the advisors that assisted us.
These are our references for the presentation, and thank you for watching our presentation.